New workbench means new camera position, which means better lighting. So this was sent in to me by another telephone collector. This is a Sage 930A power supply, as I've repaired a couple on this channel, I think, of my own. So he said that he turned the unit on and black smoke came out of the power supply. So he shipped it to me to take a look and see if I can figure out what's wrong with it. So looking at the thing, I don't see any obvious signs of scorch marks. So maybe this wasn't where the black smoke came from, but this kind of seems the most capable of producing black smoke. So this is a fairly recent power supply. It has all 1993 date codes on the parts. The capacitors seem fairly healthy. The boards aren't covered with capacitor goop, and these aren't bubbled up. So I don't know. Let's, I guess, power it up and see what it happens. I don't see anything wrong. The fan's seen better days. Okay, so I guess it's time to get out the meter, pop these plugs off of here, and figure out if it's not producing the right voltages. So on the common, 4, 5, 6, 7, and 8, it should be 5 volts. Alright, well, that's a good sign. Not common for these. 5, 6. It's weird the way the pins are labeled on this. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All right, so we don't have 5 volts. So there is something wrong with it, which actually gives me something to troubleshoot. Make sure I'm on a good. The fan is powered directly off the AC, so it'll work no matter what. Which I guess is a good idea, because that cools the whole unit. What was I doing? Right, I'm on common, so this should be minus 15, which it is. And this should be plus 15. Ooh, 9 volts. That ain't right. This one should be 52 volts. 56. Okay, that's actually quite indicative. Common, common, common. And these, yeah. So what that tells me, so the switching power supply is regulated from the 5 volt rail. That's the one that all the other voltages follow. But the 56 volt is weird because it's not regulated at all. It just comes off of the transformer and it's filtered and out to a pin. So it's interesting that it's at 56 volts. But that's because it's unregulated. So if I put a load on that, it's going to pull that down. I think I'm understanding that properly. All right, so if you have to remove this PCB, if you ever do this, there are 2 little plastic, in addition to the screws, there's a little plastic clippy dealy there, and one hiding under this transformer right there. You have to kind of reach in with some needle nose pliers and squeeze it to undo it. So I've had this board out, so I won't be able to be as surprised, but yep, there's an issue. Holy crap, look at that. I wonder what did that. The 52 volt path is through a trace on the top side of the board. There's a capacitor across it there. I think there's a diode or something there. Through an inductor to here to the transformer. Now that's unaffected. That's why I was seeing the voltage, because it's coming off the transformer and straight out. So it's still regulating, or it's not still regulating. It's still, the transformer is still operating. The switch mode side is still going. This is the ground, like I said, and this is actually connected through to chassis ground. So that, I don't know if there's a direct connection. Yeah, there is. So on the frame that you can't see that I'm tapping, it is tied to the ground. Oh, but this doesn't actually have a ground. So this thing is actually not referenced to ground. This is floating. So is this ground floating somewhere it shouldn't? Kind of scared to turn it on now. This thing's a mess. What's that? Oh, that's I think that's a lead on one of the capacitors. Yeah, so did a capacitor's dead short? Because there is one lead of a capacitor and there's the other, which you can't even see. It's so incinerated. And that's part of this pile of 3 capacitors here. Oh yeah, look at that, I didn't see that before. If you look down there, you can see that the board is crispificated. See that? Interesting. So did this capacitor short out? Okay, there's the other lead, and it is definitely burnt through. Let's put this thing on. Ohms. Now, am I measuring through the carbon? That carbon, that burnt circuit board? Burnt circuit board. Actually a pretty good conductor. 32 ohms, 33 ohms. All right, got it out. Took a bit of work. Let's see if we can focus on that. So it's a hot mess. The other terminal's there, but it's actually been melted back. That's really wild. And that's off the ground. That's what I just find crazy. I think it's off the ground. Where's the 5 volt? Yeah, because that's the 5 volt side there. Connected through a big inductor. Burp, 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 up to here to the 2 5 volt pins. Yeah. So that's the 5 volt rail. It was on the ground. It's wild. And the circuit board's all conductive. And it's burnt all the way through. So I don't know. Maybe I could take a Dremel and just cut out that piece of circuit board. But then there's going to be one less filter cap unless I can squeeze it in somewhere. Or make one of these, double the size of one of these to make up for the missing cap. I don't know, that's weird. I wonder if, let's get out the Crapotron 5000 capacitor meter. What is that, 1,000? Yeah, this thing reads unpredictably when it's, over 200 or 0. So that's, well, now it's confused because it's a piece of junk. I don't know how this thing reads when it's over. So is it saying it's, if I'm on 200, that's 3.2 microfarads. So I was trying to get a piece of the rubber from the bottom of the capacitor stuck to the other side of the board, and I pushed on it. The board just popped right through. Look at that. That is so baked. That's it's a good thing it didn't burn this guy's house down. That's crazy. Getting back to good fiberglass. Like, oh, it would have severely. I don't know how bad the damage is. I want to get to where I'm hitting good PCB, but because I can just jumper that with a bunch of jumpers. But it's like the damage goes under this section too, and that's the 5-volt rail. All right, so I'm thinking it's this capacitor because I'm looking in there and there's kind of like splatter marks everywhere, like the electrolyte from this thing blasted out. And it's not a junk capacitor. These are Matsushita. Yeah, that's what the little M in brackets means. Matsushita. Panasonic. This is all Nichicon and Panasonic capacitors in this thing. Get that rubber plug out of there. Love the smell of electrolyte. It stinks, actually. How'd that come out? Don't want to damage my evidence trying to yank it out of there. Let's chew a bit more. The case off. This is why I buy $6 nippers at Princess Auto. Yeah, there's no heat damage there. It still feels wet, even. It is still wet. You can see it. See the way the... See what I'm saying? There's still electrolyte in there. Let's get that all over my hands. So I can't wrap my head around what happened here. Either that 52 volt terminal somehow was shorting to ground, but what would have started that? But it doesn't look that heat damage. Like this heat damage is centralized right under that capacitor. That is so bizarre. This inductor, there's like melted, what is this stuff everywhere? Scrapes off. What is that? That inductor, that's the 50 volt inductor. It doesn't look like it got that hot. But it's got a pretty skookum. The center terminal is trying to find an example of one. I thought there was one on here. Oh no, it's on this board. So this is the same power supply. This is a Power One SPL53, 5 volt only output. But if you look at the two together, I'm gonna move this thing. All right, if you look at the two together, the high voltage side is pretty much identical. There's some layout differences, but you see that across different iterations of the power supply used in the Sage 930A. And that's because what this is the guys from Sage said, hey, we need a power supply with 52 volt output or a 48 volt regulated output. And we also need a 60 hertz signal, which I don't know what they're doing with it. But that's what this little connector here is for. It's got an opto-isolated 60 hertz pulse. So anyway, and so the guys at Power One said, all right, we got you. And they literally just added this section onto the PCB, and they crammed some diodes in here. Those diodes down there are the rectifier for the 60 hertz pulse per cycle output. But the high voltage side is the same. It's all the same components, slightly different layout. But I bought this when I couldn't find the chopper transistor for my other one. And in between this arriving from eBay, or between ordering it and arriving, I figured out what the transistor was, so I didn't need it for that. But it's good to have as a reference. But what's the date codes on this? So these are 94 date codes. That's interesting. So this is actually a newer board than this one. But that's a single layer. This is a dual layer. So on these diodes here, you can see these kind of studs there that's plugged into. That's what's underneath the coils. It's like crimped into the circuit board dealy. So, but it's off to the side. Doesn't make sense. And the heat was the board was oriented. You can see from which way the smoke went, which way up was, which is that way. No, it's something. That's worrying. That's bizarre. Because that takes a lot of energy. Like I said, that capacitor did not look like it was handling, it would be burnt up if it was handling that amount of energy, passing it through to ground. That's so weird. Are you kidding? A pile of ashes on my bench. So the problem I'm having here is I can't figure out a good mental model for why this would have happened. Because that's the ground. So there should be no problem with this trace being connected to ground. So if this was in a different product and it was grounded, this shouldn't arc to the chassis, is what I'm getting at here. There's no reason for this to arc to the chassis. Did they get a lightning strike? Power surge? Maybe. I'll ask them. That's the only thing I can think of. Because looking at these ends, there's a high energy discharge here. There are like lumps of melted copper stuck to that. Yeah, I wonder if that was it. That's the only thing that makes sense. What would have been the path though? Because this is isolated from the AC side. But geez. Sorry, I keep just coming back to this because it doesn't make sense that the ground bus would be that burnt out. So yeah, I can't wrap my head around it. This thing produces 5 volts at 5 amps. How was there enough energy to melt these copper traces? And those aren't thin traces. That far back, burn a hole in the piece of paper in the back of the case. Yeah, it just doesn't, like, did something find it, did it burn its way through that paper and that's what provided the energy? Was this thing, no, nothing makes sense. I think I have to plug it in and pop a meter on this to know for sure. I feel like I need to set up a bomb shelter now. All right, the stage is set. I've got this clamped onto the stub coming out of the transformer. I have the other side clamped to ground because this I don't know, did it have something to do with ground? I'm not sure. And I have this set to ohms, which won't tell me anything. Is it to volts? I'm gonna step over here and plug it in. That was a weird sound. The regulator definitely made a different noise. Definitely sounded like it was current limiting. Okay, so I'm just gonna find the comment there. -2. Oh, because I'm backwards. It's definitely struggling to produce voltage. 73 volts. Whoa. All right, I'm gonna think about this for a bit. All right, so I talked to the owner of this thing and explained to him the disaster that this board's in, and he said, just chuck it. It's not worth fixing. And I have to agree, because it's not that, I mean, these things are cheap on eBay. And that burnt area is quite large. It's probably a 3/4 inch circle. And it's charred the circuit board to the point where it's going to be conductive. It's all carbon in there, so it's all conductive. So to extract that, I'd have to route out this big chunk of circuit board here, which would probably include the pad for this inductor. So I'd have to move that. It's just it just ends up being a bit of a kludge. But just for fun, I bridged the blown out trace with a piece of solder wick, and I'm gonna plug this thing in and see if it explodes. Look, it works. A bit high. Janky though. I don't know if I trust it. I wonder if it's going to burst into flames again. Let's watch. It seems fine. Not something I'd consider safe after it did that. It's interesting it works. But, yeah. Alright, well that concludes this video. So it's been bugging me, this mode of failure. So I cleaned up the board. A lot of the char marks I could clean up with alcohol. Isopropyl alcohol. And so I had this theory that maybe it was this 52 volt rail that's here was arcing to the ground. But there's no sign of that. If that was the case, let me get zoomed in. That area which is closest to the failure, it would all be burnt. But you can see the solder mask is still intact. The solder hasn't melted. That gap, there's another one. That's the way those terminals are built. They have a gap in them because they're basically riveted into the board. So whatever happened here was somehow related to that capacitor. That really doesn't look like it was overvoltaged at all. So, yeah. But even with the board all cleaned up, that's just fiberglass from my brush right there. I'm using one of these little mode fiberglass scrubby, I think it's a contact burnisher, but they're beautiful for cleaning up really disgusting circuit boards. Aggressive though, it'll take it down to copper. Yeah, I don't know. It really, I can't fathom what could have happened unless that cap was shorted. But even then, it's not making a whole lot of sense. If that cap was shorted between there and there, there and there, that's just a 5 volt rail. Why would it? Like, it's like I said, it's like a lightning strike level damage. Look at this. That's not a little bit of damage. Anyway, like I said, the owner said, don't worry about it. And I agree. This isn't, if this was a rare piece of equipment, if this is a one of a kind, then yeah, it'd probably be worth the repair. But these things are fairly cheap on eBay, and he already has a spare unit, and he's just going to junk this one out, which I wouldn't trust this running in my own house, so I wouldn't expect someone else to run it in theirs. So this is going to go in the junk bin.